We're solving problem 12 from the 2018 F equals MA exam A. A group of students wish to measure the acceleration of gravity with the simple pendulum. They take one length measurement of the pendulum to be L equals 1 plus or minus 0.05 meters. Then they measure the period of a single swing to be time is equal to 2 plus or minus 0.1 seconds. Assume that all uncertainties are Gaussian. The computed acceleration of gravity from this experiment illustrating the range of possible values, we need to find that. So this is our theory right here. This is our theory that we're going to use in this problem. So what we can do here is we can solve for g, the gravity component in this, as variables, and then, so g is when you square this and divide both sides by t, so this is 2 pi over t squared times L. And since we have all the variables here, roughly, we have all said variables. So this is just essentially going to be about 9.9 meters per second squared. Now we wish to calculate the uncertainty, the plus or minus. So what we can do is we can do delta g over g is equal to the square root of delta length L over L squared plus 2 delta time t over t squared and square root that. Then by multiplying the g over and plugging everything in, we get that delta g is equal to 9.9 times the square root of the uncertainty for the length is 0.05 over 1, simply square that, plus 2 times this, which is 0.1 over time t, which is 2 squared, and square root this. All of this, delta g, eventually comes out to be 1.1 meters per second squared. So our answer will be 9.9 meters per second squared plus minus 1.1 meters second squared. Or no, just write all at the end. 9.9. So this answer corresponds to answer choice D on the test, and we are done.